Okay, so here is an example of what you're going to do with all of that information. We are asked to graph y equals 2x squared and compare that graph with the graph of y equals x squared. When they ask us to do that, they want us to put both functions on the same grid. So what I'm going to do is I'm going to use an xy table to help me graph each function. You guys can see I have it set up for y equals 2x squared and our parent function, y equals x squared. Remember that the parent function is kind of your starting function, and all of the other functions are kind of based off of movements from the parent function, and we'll get into that a little bit later. But as you can see, to do the xy table, you're first going to pick some x values. So I picked some negatives, a 0, and some positives. What you want to do is to pick values that are at least going to give you that nice U-shaped parabola graph. So I picked negative 2 through 2, like that. Next, what I want to do is I want to take each one of those x values and plug it in for x in my function to get me a y value. That'll be my point. So for example, I'm going to go 2 times negative 2 squared. When I simplify that, that's going to tell me the y coordinate of my first point on my graph. Excuse me. So let's simplify that. Don't forget your order of operations here. Negative 2 squared is 4. 4 times 2 is 8. So the very first point on my graph is negative 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And we put a point. What I want you guys to do is take a minute, plug each one of these x values into our function to get y values, and then we'll graph it together. Okay, so you should have taken every x value and plugged it into the function to get a y. If you guys did this one too, absolutely fine. We'll cover that one in just a second. So now we have our points, and you'll see it makes a really neat little pattern. We go from 8 to 0, oh look at that, 2 and 8. You'll see how that gives me the U shape. You can look for that pattern of numbers to tell you got your U. So let's graph that. We already graphed the first one. Now we're going to graph the point, negative 1, 2. So we're going to go negative 1, 2. Next point is 0, 0, 1, 2, and 2, 8. So then I'm going to fill in those points with a nice smooth curve. Remember, it should be a U. It can be a more narrow U, but it should still be a U-shaped graph. And we can see that my parabola has a vertex at the origin, and the axis of symmetry is when x equals 0. Now what I want you guys to do is to, if you haven't already, take each one of these x values, plug it into your parent function, and get some values so we can graph our parent function. And then we're going to talk about how they are different. Sorry for the rockin' if you guys saw that. Alright, so now we plugged in every x value and we got a y value. So now we're going to graph those points. Negative 2, 4, 1, 2, 3, 4. Negative 1, 1, 0, 0, 1, 1, 2, 4. Then we're going to fill it in with that curve. When you do this on a homework assignment or a test, it does help to do it in different colors. Okay, so we can see our parent function is in blue. Our regular function had a coefficient of 2, and it looks like it got a little bit more narrow. It's almost like someone took and grabbed that y-axis and pulled it a little bit. So we're going to call that one, it's kind of stretching on the y-axis there. okay? Okay, here is another example of a graph that we might have to do. We're going to approach it the same way, and as you can see, there is my function, and they want me to again graph it on the same grid as the parent function, which I just went ahead and wrote in. Excuse me. So what we did is we again picked some x values that we're going to plug in there to get a y value. Now, I did not pick the same x values. Here's why. I notice I have to plug in a value for x, square it, and then multiply it by 1/2. Remember that multiplying by 1/2 is exactly the same as dividing by 2. Actually, -2 in this case. So I wanted to pick values that are going to divide really nicely because I just was not in the mood for decimals today. So we're going to do the same thing. We're going to take our x, plug it in for y, and then simplify. So we're going to go -1/2 times -4 squared plus 3. We might have to show a little bit more work here when we simplify, just so we don't confuse our work. -4 squared is 16, so we are left with -1/2 times 16 plus 3. Now order of operations tells me to take -1/2 and multiply it by 16. Again, the same as dividing by -2. So 16 times -1/2, or 16 divided by -2, gives me -8 plus 3. -8 plus 3 is -5. So the very first point on this function is going to be -4. 1, 2, 3, 4, -5. 1, 2, 3, 4, 5. Down here, which is kind of weird, but we'll go through why that's correct. Now, what I want you guys to do is to take each one of these x values, plug it in, and get a y value, and then we'll graph it together again. Don't forget to hit pause when I do this to give yourself a chance to give it a try. Okay, so you guys should have taken each x value and plugged it into your function to get these y values. Now we're going to take a minute and we're going to graph each one of those points. We already graphed the first one, so now we're going to graph the next point. -2, 1. -2, 1. Next point is 0, 3. 0, 3, 2, 1. And 4, -5. So we're going to draw in that same curve. We should get a U shape. Mine looks a little more pointy, but it should be a U. And we're going to see that the way these graphs compare, it looks like my function has been flipped down, and we'll talk about maybe why that is, and looks a little bit wider. It's kind of hard to tell with just 1/2, but last time we had a integer in front of x squared. Now we have a fraction, and it looks like it got a little bit wider.